Hello students, welcome to this lecture. This is the 13th lecture on three-dimensional geometry, and here we are going to study family of planes. So basically, if we have two planes which are suppose intersecting at a line like this, there are two planes. You can consider that this hand is one of the planes and this is another of the planes, and there is a line of intersection. There is this line of intersection. So through this line of intersection, infinite planes can be drawn. A plane can be through this, through this, through this, any manner you can draw planes. Just as we did in two-dimension geometry, that if you take two lines, then there is a point of intersection of these two lines, and through that point of intersection you can draw infinite lines. So that is called family of lines. These were called family of lines. Similarly, when we are talking about planes, so we have two planes. So there is an extension of two dimension in three dimension. If you extend this board in three dimension space, so this line will extend as a plane, this line will extend as a plane, and this point of intersection will extend as a line. Everything will increase its dimension by 1 if you change this two-dimension plane in three-dimension space. Similarly, this line has changed into a plane, and this white line has also changed into a plane because we have extended the dimension, and this point of intersection has actually become a line of intersection of planes. So through this you can make infinite planes passing through this line of intersection. Actually, you can make many planes which are passing through this line of intersection of these two green planes. So if you want to find the family of planes, so there is an analogous result. Suppose this equation is u equal to 0, that is a1x plus b1y plus c1z plus d1 equal to 0, and another one is v is equal to 0. Here it means a2x plus b2y plus c2z plus d2 is equal to 0. So these are the equations of the two planes which are given. And if you want to find the family of planes passing through the intersection of these two planes, so what you have to keep in mind is that the line of intersection of these two planes, this line actually, this line is the line of intersection of these two given planes, plane number 1 and plane number 2. Any point on this line will satisfy both of these equations. So both will be satisfied by any point on this line, because this is a line which is on both the planes simultaneously. So if you take any point here and you want to find an equation of a plane, so plane is of the similar form, what you can do is you can say there is a constant k1, a1x plus b1y plus c1z plus d1, plus another constant k2, a2x plus b2y plus c2z plus d2 is equal to 0. So you can say that in short, k1u plus k2v is equal to 0 is the family of planes passing through the intersection of these two given planes, u equal to 0 and v equal to 0. Why is it so? Because the point on this line actually satisfies u equal to 0 as well as v equal to 0. So any equation of this form will be satisfied by all the points on this line, right? Now an equation of this form is also a plane because it is having linear in x, y and z, and there is a constant. Basically the coefficient of x, if you will see, it is k1a1 plus k2a2. Similarly, coefficient of y is k1b1 plus k2b2. Coefficient of z is k1c1 plus k2c2 plus the constant term k1d1 plus k2d2. So actually this is nothing but a plane. This is equation of a plane. And what type of plane is it? It is a plane which is passing through this line, because all the points are actually satisfying u0 as well as v0. So it is satisfying this plane also. So basically this is the equation of a plane which is passing through the intersection of the given two planes, and this is a family of such planes. So there are infinite such planes. Depending upon the real values of k1 and k2, you can get different planes overall. So basically for practical purpose, what we do, we generally write this equation like this, that if it is given k1u plus k2v is equal to 0, so we can also write u plus k2 by k1 v is equal to 0, where k1 is not equal to 0, obviously, then only you can divide it. By doing this, one plane from the family will be omitted. Which plane will be that? That is the plane when you will get k1 is equal to 0. When k1 is equal to 0, the plane is actually, this will vanish, v is equal to 0 is the plane, which is one of the given planes. So practical purpose, if there is a question, then the given plane cannot be asked in a question. It is already given in the question that this is a plane, but it will not be asked that find the equation of this plane, because it is already given. So for practical purpose, what we can do, we can say that let us eliminate this plane. We don't need this plane in the answer. We need some other plane. So we can write the equation as u plus this k2 by k1 is a constant lambda, v is equal to 0. So this is how we remember the family of planes passing through the intersection of the given two planes u equal to 0 and v equal to 0, where lambda is the parameter, any real number. So in this family, one plane is omitted, that is v equal to 0, because k1 is not equal to 0 as you have taken in the denominator. But we don't need that v. So if I take an example that how to apply this question, I will take a simple example now, not a difficult one. So if it is said that 2x minus y plus z plus 3 is equal to 0 and 3x plus 2y minus z is equal to 5 are two planes, and you have to find the family, you have to find a particular plane which is passing through the intersection of these two planes, passing through intersection of the given two planes. But it is also given that that particular plane is passing through, and it is passing through a point, suppose 2 comma 1 comma minus 1, 2 comma 1 comma minus 1. So can you find that particular plane? So first of all, let us find the family of plane. So this is u is equal to 0 and this is v. You can make it equal to 0 by taking 5 on the left hand side. So minus 5 equal to 0. The family of plane will be 2x minus y plus z plus 3 plus lambda times 3x plus 2y minus z minus 5 equal to 0. Now since from here we get all the family of the planes passing through these two planes except this plane which is multiplied with lambda. But obviously we don't want that plane. We want some other plane because this is already given in the question. So the same concept, that we don't want this plane as our answer because it is already given in the question. So we can consider that u plus lambda v equal to 0. Otherwise, ideally, it should be k1u plus k2v equal to 0. Now, since it is passing through 2 comma 1 comma minus 1, so it should satisfy this point. So we'll let us put x2, y1 and z minus 1. So it will be 4 minus 1 3 and minus 1. That will be 2. 2 plus 3 5. plus lambda times, and here also we will put the values. So here it will be 6 plus 2, 8, and here will be plus 1, 9. 9 minus 5, 4. So 4 is equal to 0. This is the value of lambda which is coming, which is minus 5 upon 4. So for this particular value of lambda, you will get that particular plane which is asked in the question. So when you will put this value of lambda over here, minus 5 upon 4, and you will simplify this equation after writing this like this: 2x minus y plus z plus 3, and then minus 5 by 4 and 3x plus 2y minus z minus 5 equal to 0. So this is how you can identify that particular plane which is passing through the intersection of these two planes, and it is also passing through this point. So this point is given extra in order to decide the exact value of lambda, and we want a particular plane. We don't want the whole family here. From that family we want a particular plane. So just simplify it. It is 2x and here it will be minus 15x, and when you will take LCM, 8x minus 15x is minus 7x. Again here it is minus 4y after taking LCM, and here it will be minus 10y, so minus 14y. This is what you will get here. In case of z, you will get 4z, and here you will get 5z. So 4z plus 5z is 9z, and here the constant is 12, and here it is 25. So 25 plus 12 is 37 is equal to 0. So you can say that this is the particular plane, or we can write it like this also. After taking minus as common here, this will be your answer. So this is how you can apply the concept of family of planes. There may some other condition also given. It is not necessary that it is always given that it is passing through a point. It may given that the plane is such that its distance from the origin is given. Then decide the exact plane. Or something else could also be given, like its direction ratios are given. Then decide the exact plane. So this is how we apply the concept of family of planes, students. Thank you for this lecture, and I'll meet you in the next lecture. We will study about the intersection of lines and the planes in the next lecture. Okay, students, thank you.